Hello guys, and welcome to the new episode of the series Building an Autonomous Robot from Scratch. Today, as I have promised, we will be designing the robot chassis, and I am using Autodesk Fusion 360 as my CAD software of choice. Now, you could very well choose any other software that you might be familiar with, like SolidWorks or Onshape, or you can follow along in Fusion 360. Right here we have the prototype I have designed, and so in this episode we will be designing this exact same body as our robot. So as you can see, I think it's pretty good, pretty compact, and it should be a good platform for our robot. So we will see. Now you might see that I have some components here, like the wheels, the lidar, and so on. So some of these I have designed myself, like the lidar and this DC motor. But I have also grabbed some from GrabCAD, which is an online platform where you can share CAD designs with others. I will leave the link of all the designs I have grabbed, and also the design I've made. They will be all in the GitHub repo for you to make use of them. But without further ado, let's just get started. So I have already created here a empty design, and I like to start with creating some parameters which will help us basically change the robot if we need to, just by modifying some values here on the parameters. So I have here a list on my second monitor. So let's start with M2 nut, and this is a value of 4. Now we will also need M3 nuts, and this is a value of 5.6, and so on. So I will fill this in, and once I have finished, I will be back, and I will leave the list in the description of the video and also in the GitHub repo for you to fill it up. So, okay guys, back to it. So I finished loading all the parameters. Now some of the most important here is the chassis size, or the PC size itself, like the Raspberry Pi or the Odroid that I've mentioned on the previous video. They are different sizes, so we with just changing the value here, we can adapt for the different PCs, and yeah, so on. So as I said, this will be on the GitHub repo, or if you want to make a screenshot of this, feel free to pause the video and make it. Okay, so let's start. So let's create a new component, and let's call it lower plate. A lower plate. Okay, and this will be the base. So we start with a sketch. Now, since the chassis itself is symmetric, I will just draw half of the chassis and then go from there. So let's draw here a line like this, maybe another one like this, doesn't really matter. And so what we want is a rectangle basically, and there we go. So we create a rectangle like this, and now we give it a distance. So the size of the robots, I have played around a bit, and by default the first size I tested was 150 millimeters, and I found it was a bit too squishy, so I went for 170 as the size, and this will also be the chassis size divided by 2. Okay, now this distance from here to the middle also is the chassis size divided by 2, and there we go. Now, to make the borders, I will create a circle, and I will make this circle tangent to this side, and this circle tangent to this side. So we have this nice circle here, and the distance, or the diameter in this case, is the chassis size divided by 3. And there we go. So now I will make a mirror, which will be across the X-plane, like so. And now I will make another mirror, which will be all of this through this. Okay, so we have our base chassis built here. Now, as you can see here, I have these holes, so we'll make those as well from here, I think. Yeah, can make those. So let's create circles. So we have one in the middle, and then one basically here, and then here, just short. Yeah, okay. So circle here and here. Okay, so now all these circles need to be aligned like so. And then we have an offset here of pillars offset, okay, which is 6 millimeters. And then the same for these ones, pillars offset. And then also these ones here, which is pillar offset. Okay, now all of these are the same diameter, like so. And the diameter will be 3 millimeters plus the all offset. So this all offset is mainly for printing. So I found out that with my printer, if I have a 0.5 offset, I have the size of the hole to pass an M3 screw is relatively loose. So then you might play around with your own printer and see what's best. Okay, so now that we have this, we need to make these with this with this point, and this with this point as well, this with this point. And now this to here is 25, and so this should be aligned with this. There we go. And now we can just make a mirror of all of these. There we go. And yeah, across the X-plane. Cool. Okay, so I think now we have it. Now we can extrude it. Like this. Boom. And we will extrude it by 10 millimeters. No, 5, sorry. 5 millimeters. Okay, and so we have our base plate done, our lower plate. So now the next part is to name this sketch. I like to name it so that we know what sketch is what. So let's make it base layout. Layouts. Oops. Okay. Okay. Cool. Now with this done, what we can do is start making the motor holes. Okay. So now we have 4 different circles. And then we make them equal because they are all the same size. Cool. Now this will be motor hole width, I believe. No, height. And then this to here will be motor width. Now this and this need to be the same level, and there we go, and there we go. And now this will be motor hole diameter. So the good thing about using these parameters is that if you need to change the, for example, the width and the height of the holes, the hole placement, it's very easy. You just come here, change parameters, you go to the motor hole width, and then just change here, and that's done. And otherwise you need to go through the entire basically history and find where this was made. And so this way it's a bit nicer to do things. Okay, so now we know that this and this should be symmetric, and the distance from these two holes right here is the motor hole offset, or motor offset. Now if you have other type of motors, you need to play around with this value here. This, I know that it's perfect for the motors I chose. Okay, so now instead of copying all of this here, we just do a mirror through this plane, and there we go. Now we just cut this, and this will go through the entire thing like so. Okay, so now we will say that this is the front, right, and this is the back. So we will add the Arduino and the L298N driver. Okay, so here we go. Select this face, and so we need again 4 circles for the L298 driver, and they're equal. Okay. So the lambda of each hole is L298 whole lambda plus the hole offset. Right after the hole offset there, need to change it. Okay. Now the distance, L298, I think it's the height here, and here's the width. And this needs to be also vertical lines. So let's see. This guy, I believe. No, it's this guy. Yes. So 36.74 this way. And then here we have, yeah, correct. Cool. Now we need to have some dimension from the middle, and we can place it as maybe 25. I mean, here you can play around with it. Yeah, I think 25 is good. If not, we can just change this later. And then from the middle, we can also say 25. Cool. Now we can also make the circles or the mounting holes for the Arduino. So I am using a PCB, prototype PCB. Just makes life easier, I guess. But if you don't have one, then you might not even need these holes here. And now we align this vertically, this horizontally, and this vertically, and this horizontally. Okay, so now we go here and we say, actually we don't say because I didn't add the parameters for this actually. Okay, let's do that quickly. So we need to add Arduino PCB hole width, and I don't know, so let's say 45, and let's do Arduino PCB hole height, and so 50, and then Arduino PCB hole diameter, and this is the diameter. Now we can go here and check what the values I have. So 36 against 56, so 36, 56. Okay, so 36, and then 56. Okay, so checking 56, 56. Okay. And now here we can say that we have the Arduino height. All right, and then here to here we have the Arduino PCB width, and this is Arduino PCB hole diameter plus the hole offset. There we go. Now in terms where it's placed, we can set it to maybe 30. Yeah, and then here we can say maybe 15, maybe 10, maybe something like this. We can change it later. And now we just cut it. Through hole. There you go. Okay. So actually, I forgot something, but I forgot here the offsets. So plus all offsets. There we go. Save this. And I have also forgotten something here. So this will need to be a bit elevated. Therefore, we add an offset of 2 millimeters for each of these. Okay. Now we do the same for these guys, and we can, yeah, also say 2 millimeters, I guess. There we go. And now we will turn this sketch on and then extrude this. We can extrude this by, I don't know, 4 millimeters. And then we do the same here by another 4 maybe. Yeah. Okay, so now let me rename these sketches. So these are the motor mouse, and this is, I don't know, it's ACB mouse. Cool. And now we can hide, it's already hidden. Okay. So I believe we have basically all of it now, in terms of components placements. Let's just see. Okay. Yeah, so we have the mounting for the motors and the two. Yeah, okay. So now if you see here, I have removed material where we don't need it. This mainly reduces the weight and also the printing time. So this is one good way to yeah, reduce the weight while maintaining some rigidity as well. So I guess the next step is to do this thing here. So what we need first of all is to create another sketch on this plane. And now what I like to do is just create construction line like these, and then one across here and one across here. So what I do now is I create an offset from this line, and it's not a construction line, of 5 millimeters, and then another one here. Sorry, it's not 5 but -5, and then do the same for the other ones. Like so. This is not construction line. Oh wait, my bad. This is a construction line. This is not a construction line. Okay. So 5 and then -5. Okay. So now we also need an offset through the entire part of the outside. -6 maybe. Yeah, so we need -10 or something like this. Yeah, maybe -12, -10. -12, I think it's the best. I can even check which one I did here. So where is this guy? This here. Oh yeah, okay, I see. I made an offset and then, okay, think it's fine like I did here. It's better like this. Okay, and so what we do now is we basically just okay. So now what we need to do is we need to have a platform here so that stays nice. So let's say this here, let's give it 5 millimeters, maybe, yeah, let's give it 5, like this, maybe 10. Let's do it 10 actually. Okay, yeah, I think 10 is good. And then we can so this can be intact, so we can do like a line like this, and maybe another rectangle here. So we can just say to give it 15. Actually, yeah, let's not give it 15, but let's make this line tangent with this line, like so. And the same for this guy. Okay. Okay, and then this is already there. And now we just cut these white spaces basically, like so. And we cut through the entire thing. Okay. Cool. Now to add a bit more of rigidity, I have made these connections like so. So let's make them, and you see, it's not the entire thing. Oh yeah, now that I've noticed, I didn't put one big of these in the middle, but actually it should be there. It's better that way. So what we can do now, well, we can now create another sketch, maybe from the bottom. Yeah. And now let's another line, construction line. So gonna go from this to the middle here. Same here. Boom. And from this middle here to the middle. Actually, I don't need to use here at the same time. And another one here. Another one here to there. Boom. And another one here to here. Yeah. And okay, so here, here. And in this case, you need actually to have make here this is not right? Yeah, okay. Okay, so now let's add offsets to these lines, and I will put it 2.5 this time. Minus 2.5. Okay. So also there's one here. And one here. There we go. Now, as you can see here, it's not touching anywhere, but that's fine. We can use the extend feature, and we just extend the extremities, like so. These needs, this doesn't need, okay. Find here, not here, find there, boom, find there, here again, here, maybe this needs, and boom. I think that is all. So now we can use the mirror tool, and mirror across this one. Simple, right? Maybe we might need to extend here, I'm not sure. No, it's fine. Cool. And now what we do is just, okay, see, this one needs to be extended as well. There we go. Boom, 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 boom. This as well. Sometimes this as well. I think it's okay now. There we go. So, boom, boom, boom. Like so. Okay, so now we can raise it like 2 millimeters or something. Oh yeah, okay, so wait. It's -2. Because we are drawing, oh, we are drawing it from the bottom. Okay. Okay, and that's that, right? Let's see. Yeah. I think that's good, right? I don't know how much I did here. Also 2 millimeters, there we go. Great. Great stuff. So now, to make it a bit more beautiful, we add fillets. Everywhere, basically. So let's go here, boom. There. Yeah, just add everywhere, basically, where you have these connections. Okay, guys, I think I have placed all the fillets needed. I believe so. Yeah, I think it's all. Please, I don't see any misses. Okay. So now, as you can see here, I also have fillets around these lower parts. So we will make those like 2 millimeters. Oh, 1 millimeter actually. Yeah, used to be 1. And boom. Boom, boom, boom. Boom, 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 boom. And 1 millimeter. There we go. Actually, okay, so you know what? Let's put it also just in one fillet. Like so. And then I added a chamfer to all these sides here. The knock just looks more elegant. There we go. Doesn't that look beautiful? Okay, save, guys. I always save, I always forget to save. Okay. I think we have the lower plates complete. I think. Right? So the next step we could do is we can create another component called components. Components. Very good name. Components. There we go. And what we will do now is actually place some components. So we will place the motor. Okay. Let me just edit this 180 degrees, oops, like so, and there we go. Okay. And now what we will do is make a join of this O with this O. Now, okay, so I don't like this. So let's ground this first. And now we will do the joint of this guy with this guy. Yes. Okay, so I noticed another thing. You need to make this a rigid group. And now we again try again. So this with this. And there we go. Now I like it more. And we can make a copy of this. Copy, Control E, boom, rotates 180 degrees. Move there. We will need to move up. There we go. Just make try again. Just like this. Just rigid group up. This with this. Yeah, see, I don't really like this part of Fusion 60. Rigid group. Okay. So how is it looking, guys? Pretty good. Pretty good. Okay. So next step, we will be adding the L298 driver. So we rotate 90 degrees. There we go. We'll move it here. Remove, and we do it this way. Yeah. Okay. So now we create a join where we go to this place here. And we join it here. Like so. Perfect. And the last component we need is this Arduino assembly I have here. Again, all of this will be in the GitHub repo. And yeah, boom. Not like this, but like this. And we create another join. Now, this time, this guy and this guy. And there we go. Yeah, that's basically it for this lower plates, okay? Now, what we need to do is we come here, we create a new component. And I call it middle plate. Okay. And what we will do, we will create an offset plane from this guy. Okay, and we will do plates, space between plates. Okay, 38 millimeters. It's basically just there. See? So that's basically it. And we boom. Yeah, it's basically touching, almost touching, as you can see here. So let's see. Let's hide these. Let's hide this as well. So it's basically touching. Okay. So to minimize the space. And so that it's a bit more compact in terms of height. Okay. So actually, now that I thought about it, we did not finish this lower part actually. And the reason is we need to make the holes for the nuts. So let's do that first. So we do a sketch and then polygon. There we go, and we just add them here. Okay, now that we have all of these, we create a mirror. This, and yeah. And now we mirror across this plane. See? Easy. And now we extrude all of these. Okay. Now we will extrude this, or actually cut through here, but with an offset of 2 millimeters. There we go. And now I believe it's done. So now we can move on to this middle plate. And to do this, we just create another sketch. And then we can actually come to this lower... Oh, actually, sorry. We don't want to create a sketch there. Okay, so we want to go to the middle plates and then create a sketch there. so that we have this all separated. So now we can go here to the sketches and turn on this base layout and create a projection for this entire thing. Yeah, like this. Okay, and then simply extrude all of this. Now we don't need this, all of this goes away. This. We only need the the base layout. There we go. Now we can hide this, and then we have another plate, and this plate is where we will place the onboard PC. So in this case, the Raspberry Pi or the Odroid M2 Plus. Okay. So let's just get started. Something we will need to do is a cutout for the battery. Okay, so now the battery is placed here at the back so that the weight stays in the backside, and so that we don't have the robot to do this, right? At least that's the intuition. So this battery, I think we can have it like 50-50. I believe 50-50. Let's do 40. Yeah, let's do 40. Now we will make this symmetric, and the placement of this will be 10 or maybe 12. Yeah, 12. And then we cut this out to the lower part, like so. Okay, so now that we have the middle plate built, the next thing we can do is to create the mounting holes for the Raspberry Pi and the Odroid M2 Plus. So the way we are going to do that, we simply start here in this plane, and so first things is we will draw a rectangle, and this guy will be PC size width and PC size height. Okay, so this is like an external sketch of the board, depending on the one you use. And now what we want to do is we want to set this distance here to about, I would say, yeah, we can maybe set it to 5 mil, I think. Should be good. And then we want to be symmetric, so we just do it like this. And okay, so now that we have this rectangle here, we want to place the holes, and we just do this. So place the 4 different holes. Okay, and now we say that these are horizontal, these are vertical, horizontal, vertical. And now we want to say that here the distance from the bottom to the holes is PC hole placement. Okay, And now we will have here PC hole width and PC hole height. There we go. This is PC hole diameter plus the hole offset. And then we say that this and this is equal, this and this is equal, this and this is equal. Finally, we do again the symmetry for the holes as well, like so. And now these holes here, they are relative to the body of the PC. Okay, so now we just drill or just cut the holes to the other side. And so we cut to here. Ooh, nope. To object. There we go. Now, there is an issue because so the Odroid, you don't need any spacers, but for the Raspberry Pi you will need some spacers. Now, either you don't put any spacers, or you just edit the sketch and you just create offsets here of, for example, 2 millimeters for everyone. Okay, and that's it. So you just elevate this by maybe, maybe 2 mil is enough. So we just raise 2 mil. Okay. And so I just noticed, what is this exactly? Okay. So, yeah, that's really it actually. There's not much to do. Oh yeah, okay. So we can do one more thing here. We can create here a cut hole, like a cutout, so that we can pass, for example, the USB from the Arduino to the PC. So the way I will do this is by using a slot, and I will use the slot with a center point. And so just thread like this, and there we go. So now this middle point needs to be aligned with this guy. I will give this 10 millimeters, and let's say about 90 should be enough, right? And now we should give a distance from where this stays, and let's say 20 mil, something like this. Okay, and now we cut this to this part, and there we go. Okay, we save, and now we have basically this part done. And what we can do actually is place the Raspberry Pi model in here. So okay, so one thing, no, actually, yeah, it's pretty good. Well, is it though? Because yeah, the cable will be pretty darn close. But yeah, I think it's fine. It should be fine. I mean, you could rotate this to be facing this way, but then, yeah, I mean, it depends. You might like it that way instead. It's really up to you. Let's maybe put some fillets here. Maybe 5 mil, like so. There we go. And yeah. Okay, so now let's isolate this part. We will need to place here nuts as well underneath. Yeah, let's capture the position. So let's go with the polygon again. And okay, so now we can extrude this, not extrude, sorry, cut this until the surface minus 2 millimeters. Okay. There we go. Okay, so now with this, I believe this is finished. At least almost finished. Okay, I think now it's finished. Right? So this is how it's looking. So, next part, the top layer. So the top layer, we will create again another component. We will call it top plate. And then this will be offsetted by the plate PC space B plates. Okay, and cool. So now we start a sketch on this guy, and we can just project. Actually, yeah, I can project this line, and then we just extrude. There we go. Now it's good. So save. Now, what we need here on top is, at least for now, is just this this slider, right? And I have added here a XT60 connector so that we can plug the battery and power the robot. I'm also thinking of adding here a DC jack so that we can just power via a 12 volt power supply, basically. That way, if you want to just program, for example, Arduino, you have power, for example, and you don't need to have the battery plugged in. So yeah, here. So we need to put here the lidar, and that's basically the only thing we need to on top, right? So we need to design or to have the mounting holes for the lidar. Okay. So for this part, I will actually make use of the lidar itself, because I think it's a bit easier. Okay. So the lidar needs to be faced that way, like so. Let's do a 45. Yeah, something like this, right? Yeah, so let me just check. Yes. Because this slider has like an arrow here saying that it faces forward this way. Okay, that's the reason. That's the only reason. Okay, so now we can go back to our sketch. Can draw this. We cannot draw this actually, because this drawing still did not have the lidar. There we go. And now we can just project these down, and we can hide this. And now we just so I want these are 2 mil sized holes, but I want this to be 3.3 plus the O size, right? Plus the O offset. Because I will drill this down to be 3 mil instead of 2. Yeah, I just think it's the best, to be honest. Because I think this is 2, right? Yeah, 2.5. So 3 mil, it's fine. Okay, so we just cut the hole up to this face, and there we go. And we do the nuts as well. There we go. And then we save the file. Okay. Now this one, we will leave it like it is, because I don't know. I think it's nice to have a complete plate here, you know, instead of having this perforated plate. Yeah, but if you want to be like these, well, you already know the process, right? Okay, so what else? So we want to have here the cutout for the cable. And now something about this as well is that you can then tie zip ties so that we can tie together the cables, right? Okay, so what I will do here, I will also create a slot, yeah, center to center or something like this. This is too big, of course. We'll do a line from this to pretty small, huh? Okay, I'll say 10, and then this here, I'll say 10 as well, and then this size, let's say 20. Yeah, okay, this, yeah, this is going to be 50 and 86. 7. Okay, this is just a small cable anyway. And we cut this, not the entire thing, of course, just this. Like so. And now save. We can create a chamfer for this and this of 1 mil. There we go. Okay, it's basically almost done. Huh. Look at this. So we can maybe even remove the pie for now, or yeah, it's okay. So what we want to do here is we want to make a join of this with this. And actually, no, wait. Need to first create a rigid group between these two parts, so that we don't move them. Capture position, right? Yeah. And now we can do the join. So this with this. Okay. So it should be 38. Yes. Okay. Cool. For the walls, we will create another component, and we will make a wall. Maybe lower front, lower wall. All right, so we can hide for now all of this and just stay with this lower plate. And now what we will do is, so we have this, we will create a sketch here, and we will create a projection. And now what we will need to do, we have just need to make an offset of -10. Then we need to cut a line here. and here. And you guessed it, we only need to make half of it. So we will need a line which will be here. So let's say that this is 10. Yeah, so we extrude this now 3 millimeters. And what we do next is we draw on top of this. We create basically just a wall of 2 mil. I don't want to have a chain selection. I just want the outer one. Like this. Boom. Boom. And we make a projection. This, and then we extrude this to be so basically 3, or in this case it will be plane, no, space between planes -3. Okay. Yep. Yeah. Okay, so now what we can do is do the same as that part there. So we just project this now and we extrude 3 mil -3, right? There we go. So what we will do now, we will come here and we will create a sketch here. And then we will draw like a chamfer, right? And I want this to be 45 degrees. And so this is also 45 degrees, okay. And we need to draw this as well. Okay. Finish this sketch. Now we do a sweep of this and this, and the path is basically just this. There we go. Now we have this chamfer. The reason I did this is because I tried, I don't know, maybe it was some issue, but I tried in the prototype using this chamfer tool, and it was not really working. So yeah, I decided to do it this way, and it works the same. So now we just remove waste material basically. And so what I did is you just do an offset of each hole by like 5 mil. Okay, so now we just repeat. I'm being a bit dumb. Don't need to have this one. Okay, so now we will add an offset here of maybe 2 mil, maybe, I don't know. No, this is more like a 3 mil. Yeah. Let's do 3 mil. Cool. And then I placed lines. And yeah, so now we just cut this. -3. Why? Should be -3, no? Oh yeah, right. My bad. it's up to this. Up to this. Okay, actually it cannot go until that. Right, okay, so we just go until this part. That's fine. Never mind, actually this needs to go until here, of course. And now what we do is just do a mirror of, instead of bodies features, this feature, select this plane, and boom. Look at that. Right, okay. Now, one last thing we need to put here on the bottom the size for the M3 screw head, right? And here in the top we put the nut. So what to do is we just start a sketch here. We will do the nuts first. So polygon, there we go, and boom. Okay, and now we do an cut actually, but we'll make an offset of -2, and then the distance will be yeah, until here. So we just cut this. Okay, this goes just like this. I don't need any measure. Okay, and what we do next is we make a mirror of these two features across this plane. Easy. Okay, and now to finalize the wall, well, actually no, we will still do some tweaks. Okay, so now we go here and we will create another sketch here. This time let's go through this side, make a circle. Okay, so now we just extrude this, and this from an offset of -2, and then we'll extrude this entirely, and so -2, there we go, and we still need to cut this. Cut this entirely, there we go. And you know what? A mirror of these two against this plane, and there we go. And we have basically a wall. So what we will do next, to have some ventilation, so we will create a sketch on this plane, or in this surface rather, and we will create these slots. I want this to be 3 mil, and so I want this to be tangent and this to be tangent. There we go. Now this and this, I want this to be 25, and I want this to here to be 5. And okay, let's just repeat, because I don't really know what's wrong with that. There we go. Yeah, I don't really know what's wrong with this. Doesn't really matter. Okay. So now that we have this thing built, we just need to so copy them basically, and then to copy these, and then you come here and then you say paste new, and there we go. So what I want to do now is to go up. Doesn't really matter for now. So now this I want to be rigid with this guy, and we can capture the position. Okay, and now what we will do is do a join of this guy with this guy. There we go. Okay, now let's rename this to be front upper upper wall. There we go. Is this with a yes? There we go. And then what we will need to do here is that we can just edit this sketch. And instead of this here being there, we just say that I want this to be collinear with this. And hopefully it did not. Yes, see, perfect. And actually we can even add more of these. The thing is, we don't really have the thing to make the pattern, but we just copy this and yeah, 19 like so. And now we come here and we just add these. There we go. And isolate, save, and boom. Some nice ventilation, right? Cool. So now what we will do is that we will mirror set of features components. So I want to mirror this over. So let's go here instead. X. It's the X. So it's the YZ, right? It's not the YZ. It's this guy. And then do the same mirror this guy across this guy. There we go. Cool, cool, cool. What do you think, guys? Now let's rename this to be instead of front, it's the back. Back lower, and also rename this thing. There we go. Cool. And so the idea here is that if you want to add a camera, for example, a webcam, you just need to modify a wall to make the mounting for your camera, for example. If you need the ultrasonic sensor, you just modify this wall here. And since the wall is pretty easy, and I mean, I think it's 2 hours or something to print, so it's not that waste of material, I say. If you want to upgrade, of course. Okay, so what we need is a caster wheel. So I have not tested this, as in moving the robot. So I don't know if we need a front caster wheel as well. I am assuming that with the weight of the battery, a single caster wheel should be enough, so that the robot doesn't basically do this, right? So that the front part here does not touch the ground. If I see when testing later on that this is the case, we will need to add a caster wheel in front as well, so that we are sure that we are not making the robot touch the ground in the front. But for now, the caster wheel, I have made this one right here. So the idea is this will attach directly to the wall, and yeah, that's it. And so it's basically using a bearing here, and you just attach this to the bearing with friction, and it should be there, and it should not move on. And so in order for the wheel to have friction, I came up with this idea of having 2 O-rings, which is rubber, and so this way we can have more friction to the wheel. And I have tested this, and this runs very smooth, very, very smooth, so no worries on that. So yeah, so what we will do is very simple. We will import this guy. I will leave this also in the GitHub repo so that you can use. Okay, and then rotate 180 degrees. All right. So since I don't know how big the wheel will be for you guys, and even for me, because I have done this part, right? I have this lower part built, and I noticed that here, for example, in this prototype, I have only made the hole for it, right? And I see that it's actually a bit tilted forward. And so what I will do now, instead of having this, I will have sort of a slot so that we can adjust so that it stays flush or parallel with the ground. Not flush. So yeah, let's do that. Okay. Now we will go to the back lower wall, and so let's position this. Let's position this wheel so that we have it more or less with the same, at the same height of the big wheel, more or less. Okay. So we design here so we can capture the position, and we will make 2 slots. Okay. Now it doesn't need to be a lot, just a tiny bit. So maybe 10 mil. 10 mil should be plenty. And what we will want to do is we want to position these, right? So we will make projection of these. Now we want this point to be coincident with this, and this with this. And now I don't know if we should, because this is already pretty low, right? So I was thinking, why doesn't this move? So yeah, I don't know, maybe we say half of it. I mean, it's not So for sure we want this to be coincident with this. And now we want also this point here to be coincident with this point. And now the distance to this point could be maybe like 2 mil, 3 mil, so that we can go a bit lower and a bit higher. Yeah, I think this should be plenty. Okay, so now we need to give dimensions. So we will give this 3 plus all offsets. And the same for this guy. Okay. And we will cut. Nope. There we go. So we will cut until, so let's do cut. What's the distance for now? Oh, that's fine. Okay. Yeah. Oh wait, I just noticed I gave. Oh, this is the radius. It's divided by 2. Sorry. I was like, why is this too big? Yeah. Okay. Isolate. And what we will do is we will create a sketch here. And now we will create so 2 polygons, one here and then one here, and so we can make maybe a circle even, because I don't think that will work as in a construction. Okay, and then do this concentric with this, right? There we go. And maybe even do so 3 plus all offsets. Not that it really matters, right? So now here we do M3 nuts, like this one. We make this parallel with this parallel with this, and then we connect these two, right? And I don't want them to be construction, and we will make an offset now. Again, not construction. There we go. Off maybe 2. Yeah. And we will extrude this. Like so. I want it to be joined first. So let's create another sketch. We project this line. We finish here, and then we just cut this now. We want to cut until this part. Like so. And now, you guessed it, mirror. Instead of components, we mirror features, which is this and this. And we mirror about this. There we go. Cool. Yeah. Now we can add chamfer. Okay. So the main reason we want this this chamfer is while printing, we don't need any support basically. So yeah, this is one of the main reasons why we want a chamfer. Also, why the reason why we have this like this shape here, so that we don't need any support. Okay. So you know what we can do as well? We can make ventilation here. Why not? Beautiful. Okay. Do we want to add a fillet here, like pre-mill? Yeah, why not? Why not? Fillets are never too much, right? Okay. Boom. So you know what? We will need to go and put fillets for every wall now. Okay, guys, and I have basically finished the fillets on the wall in the walls, and I have also added here ventilation from of a like a kind of a smile, and here at the back as well. Here, and I have also I did this slot here so that we can have access to the USB ports. Okay, so let's give some color to the robot. So let's go to paint. I like always to have the glossy. So let's give white to the walls, right? And then let's give a blue to the plates maybe. Yeah, look at this, really cool. And we can even give the color blue or yellow to this caster wheel, so that stays in the same color scheme. Cool. Look at this, guys, look at this. Very nice, isn't it? Okay guys, I think I have basically finished now. So I have added here the small box for the XT60 connector, and I will soon add here a circle or something for a DC jack, so that we can also plug it while stationary, so just to write code or something like that to test it. And that way you don't really need to have the XT60 the battery connected. I have also added like some chamfers here, and yeah, overall this is it. This was a long video. I think I will cut a lot of things and maybe speed up some parts, otherwise the video is like maybe 3 hours long or more. So yeah, I will see what I can do. I will try to make this below 1 hour, let's say. So yeah, if you have enjoyed, please subscribe, like, and yeah, leave a comment if you have some remarks, some questions. I will be gladly answering them. And see you on the next episode, where it will mostly be about building the robot entirely, after I have 3D printed everything and make sure everything fits properly. And yeah, so see you on the next episode.